Hey, Mr. Pham, I tried to download that handout, the diode one. For some reason, when I hit handout, it won't come down. I don't know if I'm doing it wrong or what.
Oh, that's a PDF file. You have to open and you will be saved.
Let me try again, but go ahead. Thanks a lot anyway.
Okay, so we started today. Okay, that's the last thing review on DC circuit. So that will be on the review number 2. First thing, we want to get the VB and VC and using the voltage divider law. Okay, so let's see. VB will be equal 10 times R2 plus R3 divided into R1 plus R2 plus R3. Let's just repeat it again, so that's why I'm not giving you the answer. You have to take care of yourself. Number 2, only 2 resistors in parallel. And they get a total current of 15 amp. And now they want the current on I1 and I2. You will be using the current divider law. That means I1 equal I total time I2 time R2 divide R1 plus R2. And if you want to calculate the I2, then I2 equal I total time I1 divide time R1, sorry, divide R1 plus R2. If you get any question, go ahead and ask, okay? And now you get R1, R2, R3, R4 in parallel. You can using the formula we already given to you. That means R total equal R1 plus R2 plus R3 plus R4. Okay? And now what happened here is they given you total current time 10 amp. And they want to know what is the current for I1, I2, I3, I4. So we get a new thing for you. That's what we're talking about, conductance. Okay? Conductance just a reverse of the resistance. G equal conductance, that will be equal 1 over R. Okay? And the unit will be Siemens or millisiemens. Conductance in parallel circuits are added just like resistance in a series. Okay? So the easy way to do, first thing you need to calculate the conductance Z. Okay? And equal G1 plus G2, G3, G4. Okay? And G1 equal 1 over R1. They will be 0.015 Siemens. Okay? Or equal 10 millisiemens. Then you calculate Z2 same way, Z3 and the Z4. Okay? Then you just calculate the total conductance equal Z1 plus Z2 plus Z3 plus Z4. You get to 100 milliseconds. Now, millisiemens. Here the formula I1 equal Z1 divided to Z total and time I total. That you're able to calculate the I1. If you want to calculate the I2, they will be the same. Z2 divided to Z total time I total. If you want the I3, then I3 will be Z3 divided to Z total time IT, and so on. Okay? And now you calculate telling me you get the right answer or not. I get I chose 2.5. Okay? In this case, if you want it in normal way, then you have to combine all of the resistance here. Okay? Then you can calculate the voltage across that. Then you take the voltage, you divide to the current, then you can get the current. This is another way more easier to do your calculation. Okay? Make sure you copy it. If you don't, let me know. We can move. Okay? You will be doing the same thing. Okay? That means you have to find a conductance. Same thing like previous example. And this I already given to you the answer. Okay? And now, okay, I will be using my iPad to talking a little more on the Thevenin and superposition before we finish it.
FM, can you share the previous screen we want to copy?
You mean go back to number 3?
Yeah.
No.
Go back to number 4.
Okay, let's see.
Mr. Pham, you have a great background.
Thank you. I'm too old, man. That one you want copy, right?
Yep.
Okay, hurry up.
Yeah, you can download it from the website
Take a
from
picture.
Electronic Tech.
But they download it, they don't have an answer.
It's actually all on the handout. Or everything that's shown here is on the handout.
Yeah,
This page is all on the handout.
okay,
So just go to the next page.
okay. Let's see.
Yep. Thank you.
Okay, so now I have to share, unshare that one. I share from my
If
okay,
you ever, I was just gonna say, if somebody knows how to do print screen, you can always do that and save it in a Word document. You have it
Or
there.
PowerPoint, maybe even better.
Yeah, PowerPoint is the best one if you can, if you have PowerPoint.
Usually it's landscape, easy to manipulate.
okay, so we go to number 5.
Or Google Slides.
Okay, go to number 5.
Okay.
Let's see, 15 volt. Go to one resistor here, another one here, and another one here. And they go to the current. They will be 2 amp. So R1, R2, R3. That's what they want to calculate IR1, IR2, IR3, and VB. Okay, so that will be IR3. That will be IR1. That will be IR2. Now, if you want using the superposition, that's a theory using for solving the circuitry with 2 or more source, either voltage source or current source. And now you have to do one by one. That means the first thing you have to remove, for example, 2 ampere, and calculate whatever you need for the 15 volt. Okay? Then the second one, you will be remove 15 volt and working with your ampere. So whatever you get, okay, they will be add them up. Now, in order to do it, if you want to remove the current source, then what happened? What requirement? Like yesterday, we already said, you remove the current source, you must be open. You remove the voltage source, you must be short. Okay? So now I'm talking about remove to air. So the circuitry, you can see so that will be 15 volt. Okay? And now you can see the current flow here. I1. There will be I3. And that will be I2. So that one will be telling you, you calculate I1. What I1 equal? Tell me.
15 volt divide R1 plus R2, R3.
Time R3 divide
5 ampere,
R1 plus
5
R3.
ampere
15 volt divide
divide
R1
Plus
plus
R3.
R3. The thing is, this is open. The current go to I2 will be right.
Yeah.
They open. Okay. So I1 and I2, that's the same, I3, the same current. So I1 equal I3. You get that? Okay, VB. Equal I3 times R3, right? I just given you the formula, okay? I'm not trying to do calculation. Okay, any question for that first one? Okay, second one. Now you will be remove 15 volt. Okay, so you get a short here, R1 here, R3, R2, and you get the current. So this current will be I2, okay, and this current will be I3. and the current here, I1. That will be 2 amp. So that's easy for you to recognize. First thing, I2 equal. What I2 equal?
2 amperes.
2. 2 amp, right? That's the current here. And now if you want to calculate I1 using voltage current divider, I1 equal 2 amp times R3 divide R1 plus R3. Okay? And if you want to calculate the I3, equal 2 amp times R1 divide R1 plus R3. And if you want to calculate the VB, then you take I3 times R3. Then you can take the I1 on this second here, adding to I1 on this one, the first one. I2 the same thing, adding to I2. Okay? Combine after the first one and the second one. That's how the superposition. Now I believe you can a little get along to deal with the superposition. Hopefully.
Hey, Mr. Pham, quick question.
Yeah.
Like when you figured out you use your current divider to figure out I1 and I3. Once you figure out one of them and you know that your total amps was 2, you could have just went on and said, okay, the one that I figured out, subtract that from 2, and then the rest of it go to the other one.
You mean, what do you mean subtracting?
Okay, you figured out figured out I1.
Now you're talking about the last one, right?
You figured out I1 and first, and then
Okay.
you said.
Now you're talking about remove what? 2 amp, or you talking about remove?
No, I didn't say remove anything. I'm saying
Now,
that you
depend. They have to be depend. You cannot say that. If you said remove.
No, I didn't say remove.
If you not remove, you cannot solve it.
Okay. I'm going by what you got on the screen, Mr. Pham.
That's what I said. Now you want to talking about that one, or you talking about that one? Different way.
I'm talking about the one where you remove the 2 amps.
Okay. Now, if you remove 2 amp, you agree with me, your circuitry will be look like.
Okay. Oh, I'm sorry. We're doing the one with the 2 amps in the circuit. We're doing the one with the 2 amps in the circuit. You figured out I1.
Okay. That means you're talking about remove 15 volt.
Right. Okay.
So now we deal with this circuitry here. Right?
Yeah, but let me finish. Okay, the I1, you figured that out. And then
Now, how come you calculate I1?
That's what I see
How?
you got on the screen here.
Yeah, on the display. How come you can get I1? This I1 here.
Current divider.
I don't want to take up too much time, Mr. Pham. Let's move on because I don't think you understand what I'm actually talking about anyway. All I'm saying is you figured out I1, you figured out I3. I'm saying once you figured out one of them, couldn't you find the other current by just subtracting it from I2? Your answer from I2.
Okay, I understand what your question. You can say you calculate I1, okay,
Right,
by current divider.
right.
Then you take I3 equal I2 minus I1. Is that right?
So is that good or bad?
It's a shortcut. It's a
Okay,
shortcut.
that's what I'm trying to ask them. Exactly, that's what I'm thinking. Do you have is there a shortcut in there?
Yeah, you can do that way. But I want you guys to exercise on current divider.
Okay, bingo, bingo. Okay, you answered the question. I got my answer. Thanks a lot.
Okay,
Thanks a lot.
you're welcome. Okay, let's see. Now, let's see what else. Okay, number 6. Okay, you get the circuitry. You get one source here and 3 resistors. And this equal to the load. Okay, so you get 18 volt and R1. Okay, R2, R3. Okay, what they want it into this circuitry here. Only one source and one resistor. That's what they want. And that V here they call V Thevenin. What are here are Thevenin. So your job will be calculate the V Thevenin. V Thevenin, that means the voltage across the open circuit. First thing you have to remove volt. Okay, so now I take this loop out. No more. Okay. And V Thevenin. That means the voltage from here to here. Okay. When it's open, I know for sure the current flowing here. I here have to be 0.
Mm-hmm.
Nghe nói sang cỡ một.
Okay.
Vô rồi.
Rồi, The voltage from here and here, when the voltage here and here the same. So the V Thevenin basically right here. And that to see that's very simple to calculate it. V Thevenin voltage divider law. 18 times R3 divide R1. That's what you get.
Is it 9 volt?
I don't care
Okay.
your answer, right or wrong. When we're doing the quiz, you know. Okay, and the last one, calculate R Thevenin. To calculate the R Thevenin, you have to follow the rules. If they get the source, you have to remove. Voltage source, shorted. Current source, open. Okay, so now I want calculate R Thevenin. So I redraw that one. That will be sorted here. And that R1, R2, and that will be R3. Okay, and that from the open here, I'm suppose the current coming in. That's what we call R Thevenin. The current coming in. Okay, see how they go. R1. Okay, R2, R3. So now if you support the current coming in this way, only thing what you need to do is calculate the combination for the current, for the resistance. Try to see which one in series, which one in parallel, and combine. You get only one resistor. So if you're looking in here, you can say current go into R2, then one go here, another go here, right? They're telling me R1, R3 parallel, then series with R2.
Right.
So R Thevenin equal R1 parallel R3, then adding
R2.
R2. You understand it? See, that's easy.
Mm-hmm.
That's a big problem for engineer. About over 35 years ago, I don't know how to do it. You must understand it. Okay? You done it? Then I can move.
Mr. Pham, I have a question.
Yeah.
I don't understand the value of R3 for the number 6.
Number 6, R3. R3 in here, they given you 10K. The thing is you have to get your hand out.
All right, yeah. I don't have the handout. I need to
Yeah,
print
to
it.
make sure you have to download handout for the quiz number 2.
All right, thank you.
Yeah, no
have a
problem.
question. When they mean parallel, does that mean divide by 2? Where they said R1 parallel to 3.
Okay, so we're done. And
I
now,
have a question. And I have a question.
okay, go ahead.
Okay, so what do you have R1 parallel to 3? Do we divide that by 2?
You mean number 6, right?
Number 6, yeah.
R Thevenin
R1.
equal R1 parallel R3. Do
Okay.
calculation. That means you take R1 times R3,
Oh,
divide
times.
R1 plus R3.
All right.
Then you add into R2.
Okay.
I was wondering, Mr. Pham, if some people, if they understood what those lines mean. When that means parallel,
Yeah, to start means parallel.
right?
Udah, mau pasal lah.
Mute the mic. Mute the mic.
Yeah,
Mute the mic.
try to understanding when you go to college or university, you will be a master.
Only if we know what's for dinner.
Hey guys, mute the mic.
What's for dinner?
Okay, so we're done for DC. No more DC. Okay, so you see on the display, right? Electronic device.
Right.
Okay, you get it. Okay, so this is the main thing for your tech one. Okay, you understand in tech one you learn electronic, tech two you learn digital. A lot of things will happen to electronic. The first thing, if you're looking into that, this signal will be AC. Okay, why they be AC? The reason is the signal vary with the time. Okay, that means positive here. Okay, this is the positive, this is negative. Okay, and keep going forever. Where you're looking for this, the name is the sine wave. Where you see this signal coming. Basically, they coming out from your outlet. Okay? From your outlet, that's the AC voltage. However, when they go into the inside the equipment, like microwave, heater, computer, they're not using this voltage. They have to be DC. Okay? So you can see the difference. This is the AC signal. Okay? They just go into your home through the outlet. And anything working will be DC inside the equipment. So first thing when you're looking into this signal, you understand this is the sine wave. Okay? This is the sine wave. Okay? And they will be in the time domain. Time domain, that means they vary with time. T. They can be microsecond, millisecond, or second. You get the two different domain. One we call a time domain, and the other one we call a frequency domain. Okay? So, time domain, when you're working in electronics, the equipment you will be using will be the oscilloscope. Oscilloscope, they will be display exactly what we show you. That they vary with the time. Okay? And if for the frequency domain, you want to display, they will be using the spectrum analyzer. Okay? Now this is the definition, and make sure you have to memorize the definition. One complete occurrence of a repeating wave, periodic signal such as one positive and one negative alternation of a sine wave. Okay, that means from here to here, complete one cycle. Okay, on the positive here, they call a positive alternation, and the negative here. Okay, that negative alteration. Okay, from here to here, one completely cycle. Now, what definition for frequency? The number of circle of a signal occur in 1 second. Okay, that is the frequency, and the frequency unit will be hertz. That means completely one cycle here. Okay, period. The time distance between two similar positions on a periodic wave. That means similar from here, they start go up, and from here they go up again. Try to repeat it. That's what they call a one cycle or one period. Okay, and if you're looking on the second one, same thing. However, that is not the time. That will be a distance. Okay, from the top here, go to the top here, they call a wavelength. What the wavelength? Wavelength, the distance traveled by electromagnetic radio wave during one period. That means this signal transmitted over the air. This is occupied in the air, how long, the distance occupied. Okay, and the wavelength lambda in meter equal the formula 300 times 10 power of 8 meter per second divided to the frequency in hertz. And they given you 300 times 10 power 8 meter per second. That's just the speed of the light. Okay, you just read for understand. You don't care for now. That's for radio frequency training. Now, if you're looking on the sideway here, this sideway will be displayed on the oscilloscope. I given you a very simple thing. Oscilloscope, they divide into 8 divisions. From bottom going up, count 1, 2, 3, 4, 5, 6, 7, 8 division. That's what they using for the voltage, okay, or the current. And on the left to the right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 division for the time, okay? So by definition, the voltage from 0 here go into the top. That's what they call a V peak. Or the voltage from 0 here go down to the bottom here, V peak, okay? And the voltage from the top here to the bottom here, they call a peak to peak. Now, in here they say they given a display here, 1 volt per division, okay? And V peak you can count 1, 2, 3 division. So that's why they get 3 volt. And peak to peak means on the top to the bottom here, 1, 2, 3, 4, 5, 6. That's why they get 6 volt. So V peak to peak equal to time V peak. And now VIMS. What that mean for VIMS?
Mean square.
Yeah, that means the voltage root mean square. But, we don't care on that thing, okay? However, in order, basically the voltage IMS, they just telling you one thing. You see the big sideway here, okay? You can see they get a 6 volt. However, when you apply to the circuitry, they not get 6 volt. They get what they call a VIMS. That means the root mean square voltage, or they can say effective voltage. You get a big sideway, 6 volt, peak to peak. However, using for your circuitry, they not 6 volt. They only, in this case, they calculate 2.12 volt. That's what they call an effective voltage. Now, you can see in the outlet of your home, okay, the voltage coming out. Who knows? Very peak to peak. Anyone?
So, Mr. Pham, you're saying that the RMS and the VAC is the same thing?
Exactly. In the outlet, if you connect to the oscilloscope, they display to you the V peak to peak will be 340 volt. Okay? That will be telling you the V peak will be a half 170 volt. However, when they asking about the voltage, they talking about 110 volt. They not say 340 volt. They talking about really the voltage will be using for the house. Okay? So that will be bring it up to you another thing. When you measure the voltage on the oscilloscope, only the voltage you can get will be V peak or V peak to peak. You cannot get VIMS. If you want it, you have to do calculation. That means you can take VIMS equal 0.707 times V peak. That formula, okay, don't ask me why. I don't know. Now, if you get V peak, you're able to get V peak to peak.
Okay.
If you get V peak, you're able to calculate the VIMS equal 0.707 times V peak. And next one, V average DC 0.017 times V peak. We don't care about that V average. In display, 1 millisecond per division. Okay, so if you want to calculate the period, you can say for the time, 1 division here, 1 millisecond. If they want to know what the one cycle or period, you can count 1, 2, 3, 4, 5, 6, a half, and a half means 7. 7 times 1 millisecond. Period will be equal 7 millisecond. And if you want the frequency, you must using the formula F equal 1 over T. That means 1 over 7 millisecond. You get 142.8 hertz. Okay? So every time when you see the signal sideways display on the oscilloscope, then you must be telling me, if I asking you, what we pick equal, what we pick to pick equal, what the period equal, what frequency equal, that will be okay. So any question on that?
So the period is from where to where?
Period will be from similar of the signal. Okay, you see right here. They start go up. They go down, not count.
How do you find the VP right next to BRMS?
Just let me answer that one first. How do we know that a period? That means at a similar point, you start go up, go down, it's not the same until they go up again.
Sorry. Yeah.
So that,
Sorry.
okay. Now, the other question, try to repeat for me.
He asked.
Who just asked me?
Whoever asked the question, repeat your question.
She said how you find the VP.
I mean, peak?
VP, right? You want to know how do we know VP, right?
Just BP. The one right next to where it says
RMS.
the RMS equals 0.707 times BP.
It's the same thing. It's the same thing as BP.
Okay.
VP means VP.
Okay, thank you.
Yeah, you get VP, then you can get the VIMS. The thing is when you're doing on the lab, then you have to measure. Okay, now I just show you quickly here. Okay, that equipment you will be working in the lab. You understand it's sideways coming out from that one. The name of this device is generator. Generator will be given you sideways, square way, triangle way, okay? And also what the voltage and also what the frequency. They will be connected to the oscilloscope, these two channels. Channel 1 display input and channel 2 will be normally display for the output. Okay, you want to measure voltage, peak to peak, frequency, IMF. Instead, you have to do your calculation. The one we're using at the school, they do everything for you. You want to get VIMS, they given you VIMS. The thing is, they already get a formula inside the machine. When they measure the period, they know how to calculate for the frequency. Or if you get the frequency, they know how to calculate the period. They measure V peak, they know how to calculate the VIMS. So anything they will be given to you in display in the window here. However, you must understand the thing is the company, they not like the school. The company they using their own oscilloscope. That means you only measure the time. You cannot measure the frequency. You want frequency, you have to using F equal 1 over T to do your calculation. The reason is company don't want to change the scope. They still doing a good job. How come they need to change? But in the school, we have to be up to date. So that's why we can get a new oscilloscope. And you understand they doing too many functions for you. So the cost will be more, okay? And that's the generator. On
Measurements go up.
On Thursday, lab instructor will be giving you more detail, okay? Now, this is the main thing I want to do. First thing, talking about diode. Basically, you get a piece of the silicon or germanium, okay? On the one side, they contain positive, another side, they contain negative. And that's why they call it P-time. Contain positive, and time contain negative. And the between they call it P-N junction. That means they get P-type and N-type. That is the physical for the diode. Okay, we not do much thing about physical. We're doing this thing here. Diode. When you're looking into this symbol, you know this is a diode. Okay, one anode and another one will be cathode. Okay, and the voltage across the diode here, they call it VD, diode voltage. By basic definition, what VD equals?
Zero.
I want to know what the basic definition. VD equals. Okay, now go back. I get VAB equal what? What VAB equal?
Voltage of the bit from A to B.
I set the basic formula.
VB
0.7 volts.
No. I'm talking in general.
VA minus VB minus VA.
VB minus VA.
Minus. That's what I want you to know that. When you say VAB means VA minus VB. That means A will be more potential than B. VCD means VC minus VD. So for the diode, One side anode are using A. Cathode will be C. The voltage across the diode I call a VD. What VD equal?
Okay. VC.
All right. VA minus VC. You must be understand that basic definition. So later on you understand. Okay? So that's why in here I already said right here. VD equal VA minus VC. That's the voltage across the diode. Okay? First thing. Second thing. Diode normally permit electron current. That means we're talking about current flowing only one direction. That means current can going from A to C, but they cannot going back from C to A. That's the purpose for the diode. When you're looking into the symbol, you know this is the diode. Okay? And the voltage across diode VD equal V anode minus V at the cathode. Okay? Now, first approximation. They're talking about ideal. Ideal diode means VD equal 0 volt. Okay? Remember that. Ideal means VD 0. Now, this is the sample for the diode. Okay? So, two things you must know. When you're working with the diode circuitry, you must know the diode will be conducting, or we say on, or the diode not conducting, or we say off. If you don't know they on, they off, you cannot solve the problem. Okay? Now, you can see, permit the current flow from anode to cathode, diode on, or they call a forward bias. So basically, when they on, they allow current flow from A to C. Okay? When they off or revert bias, they look like they will be open. So the current cannot flow. That's it. So on a diode, you only must know they on or they off. Okay? When they off, the current, the resistance from here to here, they will be infinity. That means open circuit. Okay? Now, second approximation. Same thing. Only thing is second approximation, then you can get VD 0.7 volt for silicon. Diode and VD 0.3 volt for germanium. Okay? Normally we're working with a silicon diode. With that we'll be telling you when in this one, on this case here, diode on. Okay? When they on, they can get the same like 0.7 volt battery. In this case, diode off. They will be open no matter what. no current flow. Okay, so in order for the diode on, then VD must be greater than or equal 0.7 volt. Then they on. If they not, they be off. I given you the example here. Okay, 5 volt here. The diode on or off?
On.
On. In order to say on, you can say VD equal 5 minus delta 0 volt ground equal 5 volt. That's why they say on. They must be greater than or equal 0.7 volt for silicon. For germanium, they up in for 0.3 volt. Okay? If you don't know, they on, they off, you cannot solve the problem. Okay, now I need it to exercise with you. Okay, first one. Tell me they on, they off.
Off. Second
Okay?
one on.
First one off.
And
This
third
one.
off.
Okay, now you have to calculate, right? A here, C here, VD equal VA, VC equal 0 minus 1 volt equal minus 1 volt less than 0 point. So they off. That means they will be open. A here, C here. Got that? Okay, second one.
On.
On or off?
On.
Okay, now I do calculation. A here, C here. VD, VA, V minus VC. Okay, 2 volt minus 2 minus 1 equal. Okay, so diode will be on. Okay, and on, then now they will be look like a battery. Positive here, negative here, value 0.7 volt or 0.3 volt. Depend, silicon or germanium. The thing is when you're solving the problem with the diode, you decide on off. Off means open. On, you're not using the diode symbol anymore. You must be substituted by the battery. And the battery of the diode 0.7 7 volt. Last one, number 3, on off.
On.
Number 3, VD equal 0 volt minus 3 volt. 0 minus.
Plus
That's
3.
why you say off. Any question?
So in example number 3, the current will actually flow even if you don't have like voltage into the A side.
I'm not quite following your question.
So what I understood about diodes is that you cannot have current flow if you don't break the 0.7 volts. So, but how can you break the 0.7 volts if you're not applying power on the
You
on
mean
the 8?
You mean 0.7 volt, right?
Yes.
That means the voltage must be higher than that.
Yes.
You,
But if you
you
in
let
example number 3, you are not applying
Number
nothing. You're
3.
not applying voltage in the A side.
A side ground 0.
Yes. So it's off, right? Because you are not applying any voltage over there to
Now,
make the barrier.
on the other side, you get negative.
Okay.
So you're doing a calculation. 0 minus 2 minus 3, that's what you get 3.
Okay.
That's why they are. They just
Right.
compare between one side and the other side. The potential, which one is higher?
Yeah. I understand that. But in the real life, will that actually be conducting current through the diode?
Yeah, then the current can go in from positive to negative.
Okay.
Okay, now, another thing you need to know. For the silicon diode, 0.7 volt. That's what they call a barrier voltage. Why 0.7? Okay, that's a 0.7. They're telling you that enough power to electron can be moving. At that, if you less than 0.7, electron couldn't move it. If they're not moving, you don't have a current. At least have to be 0.7 for silicon. For different type, like manual, they require 0.3. Okay?
Can you just go back 2 screens so I can quickly copy that? 2 pages.
Okay, just a minute.
Sure.
This one?
No, next one. One more.
This one?
Yes.
This is a handout, correct, that we're looking
Right,
at?
everything in a handout.
Yeah, right.
Okay,
I
perfect.
just wanted to get your notes. Thank you. I'm done now.
Yeah.
Thank you.
In here, I just want to help you to understand. You reading the handout. That
Yes.
makes sense to me. Okay? Okay, now I want to see how many people understand. Okay? For this circuitry here, you get 10 volt, 100 ohm, and a diode. And the question is they want to know what V out. Who can get through that?
And VO is where? Above in the A side of the diode?
I don't know, but now telling me what V out you want it equal. Everything already so. 10 volt, 100 ohm, and a diode.
Hey, Mr. Pham, can I ask a question?
Yeah.
If you go around, for instance, the top of the battery is plus. So then the resistor would be plus minus, and then the diode would be plus minus. So then that means the diode is forward biased then, right?
Yeah, if they on it, mean forward bias.
Right. So then that would be 0.7 right there.
Right.
How much is the resistance of the diode?
What?
How much is the resistance for the diode? Are we going to consider zero resistance for the diode?
Inside, you're talking about inside diode.
Yeah. So,
yeah, they very get a very small resistance. But
so
we
are we
don't
going
care.
to neglect it? Are we going to neglect it?
Yeah. We
Okay.
don't care.
.093.
Okay, what we are equal? One answer, but I don't think that is the right one.
I believe it's 9.3.
683 millivolts.
Okay, now I'm telling you. Before you want to solving with a diode problem, you must telling me in this situation the diode on or off. If you don't know on or off, then you cannot do it.
It's on.
On.
On. Okay. So first thing I say, diode on. Why they on? Now, this is a 10 volt and this is a 0 volt route. So they must be higher than 0.7. So they on. Okay. Now if they on, I have to redraw the circuit. I don't want any more diode. Now I substitute by the battery. That's what we already said. And battery positive here, negative here, the value 0.7 volt. And that will be R, 100 ohm. And that will be 10 volt. Okay, that's what I'm talking about VL. So what VL equal?
0.7.
Exactly. VL will be equal 0.7. You know why? Very simple thing. If you take the DMF to measure the car battery, what voltage you get? If you're using the meter, measure voltage on your car battery. What voltage you get?
12.6.
12 volt.
12, yeah.
12 volt. Let's just bring it up one thing. When you measure the voltage across the battery, you get that voltage. Doesn't matter what. The reason they on the car battery, they connect into the circuitry inside your car. However, if you measure across the battery, you must get that voltage. Okay? Doesn't matter where they go. Okay, so that's why you can get 0.7 right here. So you want to calculate the current I. I will be the voltage difference here. Divide to resistor. 10. 0.7 divide 100. Whatever you get.
0.093. 0.093.
Go to milliamp.
93 milliamps.
93 milliamp, correct.
Okay, any question on this problem here?
I have that circuit drawn if you want to see it, Mr. Fran.
Okay. When you're done telling me.
Hey, Mr. Pham, so
yeah,
I don't know if you're going to do another one, but if you reverse the diode, so that would be like an open then.
That's what I tried next.
Oh, okay, okay.
I make sure they already copy this thing.
All right, thank you.
Yeah, I said after, training for the diode, guarantee you will be a master. In any situation. The big thing is I only asking for understanding. Solving the problem, you get the simulation program. You can run it, you can get the answer. But I want you to understand. Thinking next week, Monday, Tuesday, still with the electronic, no more DC. Okay? Now, I get another one. Irradiating. Okay, I redraw that one here. Okay, and go here. Then that to be 1K. Okay, what VL and what current I go and asking question the same thing. Only I reverse the diode. And now you must be telling me diode on or off first.
Off.
And the answer have to be diode off. Reverse bias.
There's no current flow.
On this side you get 10. On this side you get 0. So that's why diode off. Okay? The diode off, then now you see the circuitry.
Open circuit.
Okay, so that will be plus minus 10 volt. And that will be R, 1K. That will be V out. And the current flow here. The diode off, they will be open. What V out?
0.
0?
Come on.
Or 10 volts?
10 volts.
Okay, now what I? What current I?
0.1 ampere. Sorry. 10 milliampere.
Come on, man.
0.
Oh. 0.
Open. How come current can be flow?
So we said 0 initially.
Yeah, I said no current flow.
Yeah.
You get that?
Yes.
Okay, now.
Open means no current flow, means 0 current.
What you say?
Hey, Mr. Pham, up top, don't you have V out equal 10?
Not yet. For now, I know for sure I equal 0. Right?
Right.
Okay. Now, the voltage drop here. VR equal I times R. What VR equal?
0.
0.
0 volt. Okay? And now you get a 10 volt on this side. And basically they drop 0. The other side they must be
10 volts.
10 volt. They not drop anything.
Oh, that's why. Okay, now I understand. 10 volts, but no current.
That normally question you get a technician interview job. They asking you. If you say 0 volt, they send you back to the school. Okay, last thing. I want to talk to you before we quit.
Or your and then I or the current times current is 0.
Five volt, 10 volt, 15 volt. A here, V here. What VAB voltage equal? You get a 3 battery.
30 volts.
5 volt, 10 volt, 15 volt. That's the way to connect. And I want to know what the total voltage.
30.
Add them up. 30 volt. Okay? If they connect positive to negative, add them up. And now, if you get the power supply here, connect to another power supply here. Okay, A here, B here, 10 volt, 5 volt. What voltage VAB?
5 volts.
This is a connect positive to positive. Then the voltage have to be the difference. 10 minus 5 equal. That is the way battery connection. That are easy. However, if the people not pay attention, you still get a problem. Okay. Last one. Last one.
What's up? What the heck?
Mute Kumi.
Sorry.
Okay, so that is the one will be saved for next meeting. Now, if you don't know or you try to do it, okay, you can run your simulation. Then you can see you get a right or wrong.
You can do, hey, Mr. Pham, this can be done on PSpice?
Yeah, using the PSpice.
Oh.
And run the simulate.
All right.
It tells you every voltage, every current.
Mr.
However,
Pham,
before you do it, try to do calculation first to see how much you understand.
The diodes are forward bias.
Mr. Pham,
Yeah,
for second circuit, what is the value of R1, R2, and R3?
value of what?
For the second circuit, what is the value of R1, R2, and R3?
Okay. Thank you.
Yeah, good catch.
Okay, so
That
this
would
give us you 1K.
gave us an excuse.
1.5K. 2.5K. Thank you. The thing I want to quit, so that's why. We go slow. Make sure you're able to follow it. Okay. And again, nothing for free. This program, you don't have to pay any penny. However, you have to spend time to study. Okay. If you confusing anything, you can text me. I can online try to help you understand. I already retired, so that's why I get much time.
It's your second job, Mr. Pham. In 20 more years, you can retire.
Yeah, I get 27 years at the engineering and 35 years and more for the school.
Pretty good, I'd say.
So is Lowell going to show us his Faustet or something?
I don't need to. It's all right. I mean, Mr. Pham wants to teach him a particular way. The mathematics more important.
Can we run this on FAT? Does it have to be PSpice?
Hey, Lowell, can you do it on Faustet?
Oh, that's asking Low, not me.
I have the first circuit drawn already.
Oh, you want to try it now?
Well, if you want me to, I can show the first circuit.
I can let you guys.
Hey, Lowell, can I say one thing to you, see if you agree? When you go to Faustet.com, to get to that circuit part, you got to go Faustet.com/ and then the word circuit.
Look like you can share the screen. I'm really interested on your program, but at this time I'm still too busy.
So we can actually also use the software PHAT, correct? PHAT. It doesn't have to be Spice.
PSPI, okay, but they're not good like this software.
Okay.
See, that is all exactly the same circuit we get. Then they can tell you what voltage or what current. Can you display the voltage be after diode?
I use this file stat for the assignment number 5. And if you lay it out exactly how it is on the Excel spreadsheet, it actually gives you an error for the wiring. You need to have all the circuit legs with an individual ground, not a one path back to ground.
There are some quirks, definitely. If you slowly work with it, you can figure out just some basics. Just remember, you can highlight each component like the diode, and then the lower right shows you value at the time that your voltage and current is flowing through the component.
Hey, I'm just asking, Lowell, did he want like the 10 volts down by the battery, and then where the diode is at, put like 0.7 or something like that? Is that what it was?
Yeah, they're supposed to be 0.7. However, on this, it's 0.5. So that's why 10 minus 0.5, you can get 9.5 volt.
So this is not a silicon? Mr. Pham?
Yeah.
So you said 0.5. Is that for silicon? Because, I mean, is that for germanium? Because silicon is 0.7.
Yeah, depend on the diode.
Okay, so Lowell, what diode is this? Is this a 0.7 or the 0.5?
It provides a default, so the default 0.7 approximately. If I want to add others, there are a list of diodes. The default 0.7, and then you have to look at the specs for the other ones.
Okay. So this one but this one that you're using here is 0.5.
It's considered the default basic 0.7. All right, so like say if I try germanium, right? That's what was one of the references from the instructor Pham. So I set the reference for this diode here for germanium. That's specific to that specification of that diode. So you have to look up this germanium diode information and look for the specifications. That's a PDF. Always reference your PDFs for all components. They'll tell you exactly how that component is supposed to work.
Yeah, but that's okay. Either 0.7, 0.8, 0.5. We don't care.
There's not much of a difference.
Yeah, depend on the diode. But normally 0.7 for silicon.
I can draw the other circuit real quick if you want me to, Mr. Fry.
Okay, so.
All All right, just wait and just talk about it next time.
Okay.
All right, night.
Yeah, that's good enough. Okay, any more question, anything?
Enjoy San Francisco, Mr. Tom.
That's a nice city, yeah.
And we'll see you guys next week, okay? And by the way, I forgot one thing. I want to show to you, okay? This is the list for texture. If you're looking into that, you can see who will be on texture. Okay? We get around 41 students on texture. So make sure you get your name and be here tomorrow. Okay?
I have question actually.
Yeah.
Until now, I confusing about the schedule for the Tech 1. We are taking one. It is one is Monday and Thursday. It is Tuesday and Thursday.
Monday, Tuesday, Wednesday, Thursday.
It's 4 days.
4 days.
Okay, thank you.
Take you only 1 day
Okay, thank you.
on Wednesday. If you already been last summer, then you can go into take you lecture.
Thank you.
And you can do the homework on Tech 2. If you get enough, everything good, and next semester you need to collect enough hour. And also we'll be doing the lab. You don't care much about lecture.
Okay, thank you.
Yeah. That's the thing on of the people. 41.
So going forward, the Tech 1, let's say, then there will be only one instructor, or will it be you and also another instructor?
You mean Tech 1, you see me on Monday, Tuesday, right?
Okay.
And see the other instructor will be Wednesday and Thursday. They are the lab instructor.
Gotcha.
Normally, when we return to the class, so they're not teaching anymore. The thing is they have to teach the lab inside the class. They have to help you how to do the lab.
Okay, I see. Yeah, piece by simulation and so forth. Okay,
Right.
I got it now.
Only one giving the lecture will be myself.
Okay. So Thai is more like a lab. Okay.
Yeah, everything will be posted on the website. You just have to do is just look at the website. Who's would be the instructor for that particular day.
Thank you.
Okay, you're welcome.
Make sure when they allow your guys to go back to do the lab and they're not teaching anymore. Only you get 1 day for me, take 1 day for take 2. So I will be easier. Okay?
Okay.
So, good night.
So wait, one last question. Sorry about that. For Tech 1, Wednesday will be Thai then, right?
Yeah, Mr. Thai, Mr. Ho.
Gotcha. Or Hope.
On my side, I got me and Mr. Tuan Lee.
Okay.
He will be review for your guy.
Yeah, just look at the homepage on electronic.tech and it has the schedule right there.
Okay?
Thank you.
Yeah, good night.
Bye-bye.
Bye-bye.